All right, so we're going to start on chapter 6, which is on continuous probability distributions. So recall chapter 5, we were discussing discrete probability distributions. So let's just recall that we had these two different or general classes of random variables. The first was discrete. We said it was discrete if the random variable can assume a countable number of values. So with our examples, we said if we flip a coin, there are two outcomes, right? Heads, tails, just two. Or if we roll a die, there are six outcomes. We could roll 1, 2, 3, 4, 5, or 6. So we can count all of those possible outcomes in the discrete case. But we're now moving on to the continuous case. So we would say a continuous random variable is a random variable that can assume values corresponding to points contained in any interval. So that interval could be really anything. So just two quick examples here. This is negative infinity to infinity, so that's like truly any values. Or we could say limit ourselves to just the values 0 and 1. That'll really just come from the context of the problem in terms of what interval we're talking about. So, all right, some examples, we could measure the height of people, the weight of people, time until some event, say annual rainfall. And in all of these cases, notice that like there's no such thing as like negative height, negative weight, negative time. And so if we were going to define the intervals for these, we might say, okay, these could range from 0 to, technically any positive number. If we think about time until an event, it could happen immediately, so time 0, or it could just never happen, and so time until some event would then become infinity. Okay, so the rest of these notes that we're going to be discussing, we're going to be focused on just the continuous case from here on out. So continuous random variables and continuous probability distributions. Okay, so after that quick intro, let's now actually define this. So a continuous random variable is a random variable if it can assume any value over an interval. And as we said, or we already just talked about, this interval can be anything, so kind of relisting them, it could be 0 to 1, negative infinity to infinity, or just generally any values a and b, where we can determine what those values are. So one important thing to note is that the probability of any single point, so let me call that the probability that our random variable x is equal to any just number. I'm going to call that number a. Any number a is always equal to 0. Probability of any single point, or the probability x is equal to a, is 0. Why? And that's because the number line is infinitely dense. So that means we can get infinitely close to the value a without ever reaching the value a. So what we're going to do, or first let me note, so as a consequence of this, so as a consequence, the probability that, let's say, x is bigger than a would be the same as the probability that x is bigger than or equal to a. And same in the other direction. And probability that x is less than a would be equal to the probability that x is less than or equal to a. Why? And that's just because probability x is equal to a is equal to 0. So this was not the case in the discrete sense, right? The probability x was, say, less than or equal to 2 was different from x less than 2. But in this case, we're going to say they're the same thing. So because of this, we're going to have to define probabilities over an interval. So just generally speaking, we're going to just say a probability that x is between some two values, a and b. This will be the area under the curve between a and b. So for anyone who's taking calculus, we would create a curve and then find the area between 2 points under that curve. We're not going to worry about that, but just so we know the precise definition. So let's just give a quick example to this to make some sense of everything. So let's say, what's the probability that it takes exactly 10 seconds to download a file. So let a random variable equal the download time. So let's just note that we can get infinitely close to the number 10 without ever reaching 10, right? It could take 9.999999 seconds to download, or it could take 10.0000001 seconds to download. So the idea is that we can get infinitely close to that 10-second mark without ever actually getting there. And that's why we're saying the probability that x is equal to any value, so in this case, the probability x is equal to 10, is always 0. So because of this, this is why we are going to define probabilities over an interval. So let's just give a couple examples. So instead of x equal to 10, we might be interested in, say, the probability x is bigger than 10, or let's say the probability x is less than 10, or we could say something like the probability it takes between 9 and 10 seconds. So x is between 9, or say 9 and 11 seconds. In all of these cases, these probabilities will now be greater than or equal to 0. So when we define this probability just equal to one single value, x equal to 10, we're saying that is always, without fail, equal to 0. So to get around that, we're going to define probabilities on intervals. So we could say x bigger than 10, less than 10, between two values, in this case 9 and 11. And here we can actually find probabilities that are not 0.